More advanced techniques and more advanced theoretical tools to understand the mechanism in biology.
The history of astrophysics at Berkeley, and particularly in the physics department, is really wonderful. There's been a number of really fundamental discoveries made at Berkeley, leading to some recent Nobel Prizes.
The greatest strengths of this department are unequivocally its people. It's the faculty, the students, the undergraduates and graduate students, and the staff.
My research is focused on the study of nanostructures. I'm an experimentalist, and so I perform experiments on different types of nanostructures. Some of the potential applications of my research would be, for example, in the miniaturization of different kinds of devices. As you make devices smaller and smaller, people are interested in incorporating nanostructures into electronic devices.
I have developed a fluorescence technique that can locate the position of one dye molecule with 1 nanometer precision. And we apply this method to understand how molecular motors walk inside cells. These are nature's tiniest bipedals.
In my research, we build telescopes and detectors that go behind the telescopes, and these are all to look at the cosmic microwave background, which is the faint radio background radiation that's left over from the Big Bang.
My research overlaps considerably with the work of condensed matter theorists.
We are in an era where there is a very close connection between experimentalists and theorists. There is a lot of interest by many theorists in the results that we're producing.
Collaborations amongst physicists are a crucial aspect. You don't do it by yourself, basically. Once we have a theory and we're excited about it, it's straight back to our experimental friends to figure out how can we test this theory. And I think that's, in a sense, the most exciting bit.
So really we do everything from A to Z that you need to do to answer the physics question. And that's very characteristic of a physics department approach to doing research.
Students in the Berkeley Physics Department have an enormous range of opportunities. The researchers here are engaged in some of the most exciting research anywhere. There's just an enormous range of opportunities. I think it's just a great place to go to school for them.
At graduate school, you're learning how to think as a physicist. You're really learning these tools.
Advanced Lab is taken by all of our physics majors, regardless of whether they're interested in being an experimental physicist or a theoretical physicist or a banker or a teacher. These people have been doing book problems and learning out of equations for years, and here's a chance to confront that with nature. You'll be learning about quantum mechanics, you'll be learning about electricity and magnetism, you'll be doing all sorts of work in various courses that gets tied together here. So we consider the Advanced Lab the capstone of the physics major because a lot of pieces lead up to it and it ties it all together at the end.
We saw that there was a big problem with retention in physics, in that students who came into physics often just decided or were told that it was too hard.